Okay, so as we discussed last time, now we're gonna create a model considering only my gene column. And in this particular case, I'm gonna create a logistic regression with respect to my SGD classifier. So I'm gonna use the basically SGD classifier to do that. And at the same time, I'm also going to use my calibrated classifier, which I explained you in the last lecture, and we will be doing the Laplace smoothing if required. So let's go ahead. So here you can see here that I'm going to use one of my alpha parameter. Again, that regularization hyperparameters are required in SGD classifier. I'm also going to use L2 classifier in this case. So you can see that basically I'm going to use this L2 as penalty. I'm not using L1 norm, which is basically, so I'm going to with the L2 distance calculation and all. And I'm going to use this is loss is log, which means that I'm going to use logistic regression. But you can notice that this part I'm using it as a hyperparameter. So I'm going to run this algorithm for various value of this alpha, and whichever alpha is going to give me the best result, I'm going to just take that up as a final result, right? Now here what I'm doing is I'm basically doing this fit part, and you can notice that I'm using one hot encoding. So the way it works is that if I go back and understand this point, so if I go to one hot encoding, even if you have, let's say, huge dimensions, even in that case your logistic regression, LRSVM, these kind of models works really well. And similarly, if I go for your response encoding, so response encoding, you have like naive Bayes, random forest, okay, or basically these, or KNN, I can also put KNN to it. So in these cases it works. Even naive Bayes, you can use it for one hot encoding, that's not a big problem. But yeah, for random forest and KNN, definitely you have to go for a response encoding. So that's where we do it. So since we are going to use here logistic regression, I'm going with one hot encoder. But I would leave this as a homework exercise for you, that you can play with other models with only gene and see that how your log loss comes out to be. And you can notice that I'm using something called as calibrated class of classifier here. And if you look at this, what basically we are passing to it, we are passing this model, and we are using the sigmoid function just to ensure that we return everything in the probability format. And once we have got that, we are taking our one hot encoding data and basically going to train this model, and after that we are going to predict, and in the last we are going to use log loss, right? So that's what we have done. Now let's analyze this output which we are going to get. So here you can see that we got the value of for various alpha, like we have taken one alpha as 10 to the power minus 5, and this and so on, and we got for every different alpha we got basically different basically log loss. And if you look at it, this log loss seems to be minimal, which is coming from 0.001, right? So that's what basically we are getting the minimal log loss. So we can choose this alpha and go ahead with this. So what we're going to do further, we can also plot a graph and see that which is giving me minimal. You can see that when alpha was near to 0.001, maybe that's where it's going minimal. And even after that, what we can do is we have just computed this, but now we need to also choose the same alpha and go ahead and calculate for my testing loss. We will also do it for the cross validation loss also, just to have our comparison ready whether the model is overfitting or not. So let's do that. So what we are going to do to achieve this, we are going to now we have already got 0.01, which is going to be stored in best alpha, and after that we are using the same L2 Lagrange logistic regression. Everything is good. Created a model, we fitted this, everything is all good. We are using calibrated classifier, and in the last we are creating the log loss for each, right? So we are going to do a log loss for test, for cross validation and so on, and this is the value which we are getting for each part. So for with only gene column with a one hot encoder, logistic regression plus calibrated classifier and so on, we got our log loss value to be this. And if you look at this, this is very less in comparison to what my random model was giving us. So that's a very good insight what we're getting here, right? So this is telling me up that my model is good, not that bad, right? So which means that with gene column is, it's definitely having a good impact because this is much lower value in comparison to my random model. Now, one more thing which we also want to look at a lot of the time, that how stable is my model. Now, when I say stability, what I mean by that? Now, you have gene, and since it's a random distribution, there is a possibility that maybe you have genes basically which are here in the training set, and only very few are coming in my testing set. So this is, let's say, my test set, and this is my train set, and let's assume we do also have a cross validation set. So if this overlap is low, okay, so because there's a possibility that maybe in the gene, some gene value which is there in train set but not there in the cross validation set, right? So that's the possibility. So that's not going to overlap. So we definitely want to ensure that I do have a good overlap. So more the overlap, better it is. We definitely want to make sure that if I'm training something on some gene data, that should be present in my cross validation. It should not happen something like the case where I talked about Laplace smoothing, right? So that sort of thing should not happen, that in the test data something comes up but I have not even done any training on it. So though we have the solutions for it in terms of Laplace smoothing, but it's not still a great idea. So we do want to have the very less part. So if the more overlapping it is, that means the data is quite stable. My model is also going to be stable. So that's what we are going to look at here. So you can see it in this case, it's telling me that my testing data, if I have 665 points, 639 are common in my train set and my test set, which is good. Because if I look at the percentage, I have almost 96%. Similarly, in cross validation also, with the train set, if I compare, we do have 96.42 points which are overlapping, which is good. So looks like my gene column is going to be quite well, in this case it's going to be good overlapping, so it's going to be stable, and even my log loss is good. So gene column is definitely important for my classes in this case.